Good morning. This is class 3 of our chapter electricity. Now, last class we have studied about transformers. Now, in today's session, we will learn about generator. Okay, what is electricity generation? It is the process of generating electrical energy from other forms of energy, and a device that is used for this purpose is called electric generator. That is, generator is a device that converts mechanical energy into electrical power. Now this mechanical energy can be anything. It can be water stored in dam, or it can be wind, then tide, waves, temperature, that is high temperature created due to nuclear reaction, steam, gas, coal, geothermal, etc. So the process of generating electric energy from other forms of energy is electricity generation, and the device that is used to convert mechanical energy into electrical power is called a generator. An electromagnetic generator was invented by Michael Faraday in the year 1831. Now let us see how that generator looks like. It consists of a loop of wire, that is a coil of wire rotating in a magnetic field with the help of an external source of energy. Now this external source of energy can be water falling from an altitude, maybe water falling from a dam or like that, which is a hydroelectric. Then it can be either wind, steam, etc. So you have a loop of wire rotating in a magnetic field with the help of an external source of energy. Now, when this water falls, what it do is that it turn the blade of the turbine, which is attached to this loop of wire. So this external source of energy will turn the blade of the turbine, and when the turbine turns, it is attached to the loop of wire. So that loop of wire will also start rotating, or it will also move within the magnetic field. As a result, a current is produced, or a current is induced in the loop, and many slip rings, you can see that slip rings in the figure, and it is attached to each end of this loop, and this slip rings actually provide the external connection through some brushes which is in contact with this ring. So slip rings are mainly used to provide connections. So this external source of energy, which is a hydroelectric power or a water falling from a dam, it will actually turn the turbine. When the turbine turns, the loop of wire which is attached will also turn, and it will start rotating in the magnetic field. This process produces a current in the loop, and as a result power is produced, which is transmitted by using these slip rings. So the actual design is actually complex, but maintenance also is very critical or crucial. So this is a schematic diagram of an AC generator. Next is about hydroelectric power generation. It is nothing but the production of electric power from gravitational force of falling or flowing water, which you already know, and it is a source of about 17% of the world's total electricity is hydroelectricity, and about 70% of all renewable electricity is also hydroelectricity. So hydroelectricity is one of the cheapest forms of renewable energy, and this hydroelectric power comes from potential energy of water stored in a dam. That is, when water is stored in a dam at very high altitude, so it possesses high potential energy. So using this potential energy of this stored water in the dam, hydroelectric power is produced. Then how it is produced? That is, the potential energy of the water stored in the dam will drive the turbine which is connected to the generator. Now when the turbine turns, the generator also will run, and which will produce power, and this the power that is produced mainly depends on two factors. One is volume of water flow, and the other is height of the water level above the generator. Now this power, the water is delivered from the reservoir to the turbine using very large pipes called penstock. Now the turbine rotates the generator and produces electricity, and this electricity is stepped up using a transformer and finally delivered to the desired locations. So there is a formula to calculate this electric power generated using hydroelectric station, which is given by P is equal to rho HRGK. P is power in watts, rho is density of water, H is height in meters, R is a flow rate, G is acceleration due to gravity, K is efficiency of turbine. So this is a schematic diagram. From this you can explain how hydroelectric power is produced. See, you can see a reservoir on the left hand side. There water is stored in the at very high altitudes, and it possesses high potential energy, that is, it is stored in the dam. Okay, now this water from the reservoir is transmitted to the turbine using very large long pipes called penstock, you can see here. And so when this water reaches the turbine, what happens to the turbine? It will turn. When the turbine turns, the generator which is attached to it also will run at a very fast speed, and it will produce power from water. This power is later stepped up using a transformer, and finally it is distributed. This is how hydroelectric power is generated, and the electric power that is produced is given by the above formula. Hope this is clear. Now this is a statistical report of the water power, that is hydroelectric power produced in it with using the water in Idiki dam. It is dam. It is about 167.68 meters arch dam, and it can produce nearly 780 megawatt of electricity using 6 turbines. That means each of these turbines has a capacity to produce 130 megawatt of power each. So 130 into 6 will be 780 megawatts. So that much power it can produce. And the water from dam falls. It is falling through a height of about 669.2 meters to produce electricity, and the power generated is in this powerhouse station at Moolamata, and which is about 43 kilometers from them. This is how hydroelectric power is generated at Idiki dam. These are some of the advantages of hydroelectric power. First of all, it is flexible source of production, and depending on the demand, the production can be increased or decreased quickly, and the production cost is low. There is no emission of greenhouse gases during electricity production. Reservoir can be used for other purposes such as water, sports, tourism, etc. These are some disadvantages. That is, large reservoirs of hydroelectric power station result in submersion of extensive areas of land, that is submerged. Then it will destroy biological rich and productive land and forest, and complete destruction of local ecosystem. These are some of the disadvantages. And building large dams and reservoirs often involve displacing people and wildlife. Then failure of dams due to natural disasters can be catastrophic. It can cause great damage to human life. Then the last session is wind power. As you already know, wind results from motion of air. The kinetic energy of wind is converted into mechanical energy or electric energy, and that's how wind power is produced from wind. Now, energy of wind can not only used for electricity production, but they can also provide mechanical power such as water pumping, grinding grains, etc. In India, this wind speed is very low, but high wind speed is obtainable in certain coastal areas like western Rajasthan and in some parts of central India. These are some of the characteristics. It's a renewable source of energy. It's non-polluting. In small scale, it is less costly, but in large scale, it is more expensive. Then noisy during operation. Large areas are needed for large scale electrical power production. That is, you can see windmills installed in very large places. So large area is required for the installation of windmills, and hence the production of power from wind. Okay. Now, wind energy conversion devices are mainly known as wind turbines, and wind energy is converted into electrical energy by connecting the turbines to an electric generator, which we already told. Then wind speed increases with the height from the surface of earth, that you can notice. So at a height of 10 meters, wind speed is about 20 to 25% greater than at the surface of earth, and that's why wind turbines are always positioned on tall towers. So this can be a possible question. Why wind turbines are always positioned on tall towers? Why? Because as height increases from the surface of earth, wind speed also increases, and more power can be achieved by using from that wind. Okay, now this is a schematic diagram of wind turbine power generation system. This is a windmill and all. Now the energy available in wind is what? It's kinetic energy, but the energy stored in energy of water stored in a dam is potential energy, but here energy in wind is kinetic energy, is given by half mv square. Now suppose that a volume of air passing let a volume of air V passes through an area of cross section A, then that no that is suppose that the air has got a velocity V and it is passing through an area of cross section A, then volume is calculated as A dot V, A into V. Okay, so then mass will be volume into density, because density is mass by volume, so mass will be volume into density. So mass is equal to AV, that is volume, into density, that is rho. Okay, so kinetic energy half mv square can be written as half rho AV cube. Now so from this equation it is clear that the most influential factor of non-wind energy is wind speed. That is in half mv square, in place of m you are substituting AV rho. That is how you get half rho AV cube. Okay. Now in commonly used variable speed wind turbine generators, the frequency of voltage output varies with wind speed. However, this varying frequency electricity cannot be directly connected to transmission system. So what we are doing is we are using a frequency converter to convert it to the to convert this generator output to 50 Hertz AC signal before it is fed to electrical grid. So a frequency converter also is used for the particular purpose of conversion. So that's all for today, and in the next class we will learn about solar power. Okay, so here you have to study what is wind energy, then its advantages, disadvantages, which is very easy for you. So please read through it. Okay, thank you.